This is our first lesson in if statements. If statements are important in any programming language. It helps the program make decisions where the outcome, um, where it can provide a variety of outcomes. All right, an if statement is just like it sounds. If this happens, do this. All right. I'm going to go through about as bare bones basic a program as I can to start out with to kind of give you an idea. Here we've got the basic shell of a program. Pound include IOStream using namespace, int main, and then we ended up with return 0 at the bottom. For this program, I'm going to simulate, pseudo simulate, if that's a word, a blackjack program. Blackjack equals 21. So I've declared a variable, then I assigned it a value of 21. I've made it an integer because, well, when you play blackjack, you definitely don't use decimal points. Then I've got another variable called int total. In this program, I'm going to ask the user, I'm going to see out enter total, whatever score that they got. And then I'm going to input that total. All right. I'm going to assign the value here for the total I declared up here. All right, and here's where we start our first if statement. Based on what the user entered, if that total, the number the user entered, is greater than 21, I'm going to see out, sorry, bust, you lose. If they enter 21, if total is greater than 21, this won't happen. If they enter 19, all right, this won't happen. So for this line of code to be used, this condition has to be met. All right, I'm going to run this program. Enter total. I'm going to go ahead and hit 23. Sorry, bust, you lose. All right, that condition was met. Total is greater than 21. You lose. Real quick, I'm going to run it again and run a 21. You can see nothing happened. After I entered 21, the program ended. This line of code was just skipped over because this condition wasn't met. All right, I'm going to do a couple more things with this. This is like our very first if statement. All right, I am going to put, I'm going to change this greater than. I'm going to change this to a comparison equals. Look, two equal signs. We haven't seen this before. This is a comparison, and I guarantee this is a mistake you're going to make on your program at some point. When it's two equal signs, it's a comparison. I'm comparing the number to the variable. One equal sign is up here, right? That's when I'm assigning value. Two equal signs are comparison. One equal sign is I'm sorry. Two equal sign is a comparison. One equal sign is an assignment. So now I'm telling it, compare if total equals 21. Let's change this output to you hit 21. All right. So for this condition to be met, total has to equal 21. Let me run this real quick. All right, let's go ahead and hit it. You hit 21. So the condition was met. I entered a 21. You hit 21. Now, any other number I enter is going to just get, the outcome is just going to get passed over. So there was 20. I'm going to run this again. 22. Everything gets passed over. Right? You can also do this with a less than. So we've had greater than. This is equal to, the double equal signs. One of the more important things out of this lesson. All right. Let's make it less than or equal to. So if total is less than or equal to 21, you win. Right? This is less than, equal to. It can be, yeah, I can roll a 21. The condition is going to be seen as true, and this line of statement will be used. If I put a 20, 19, so let's run it and see. Put a 20 in there, you win. I put a 21 in, which is the equal to, you win. All right. Like on all this code, I suggest that you type it in yourself and play with it a little bit. Just watching this video, yeah, you can get some knowledge out of it, but it's still not hands-on. All right, our next program, and these next three are going to be straight out of the book, right? I want to point out that the book uses, um, the book does real well with its commenting. Some places it actually comments too much, but look at the first line. It tells you everything you need to know about the program. This program, this program averages 3 test scores. Well, it does more than that. We're going to be using a comparison operator and an if statement. All right, let's walk through this. For this one, we've got IO manip in it. We're going to use a few of the things that we've used before. Remember IO manip we use for set width and set precision, right? And the using namespace. So everything here you've seen before. All right, the first thing I'm going to do is declare a variable, an int, high score equals 95. All right, basically this is supposed to be based on, past data somewhere, the high score up till now is 95, right? Then we're going to make an int with 3 variables, score 1, score 2, and score 3. So that's the 3 test scores we're going to enter. And then we've got double average. We're going to take the 3 scores that the user enters and we're going to put it into an average. And then we're going to compare it to this previous high score 95. Lines 13 and 14, line 13 says just enter the 3 test scores and I will average them. Okay, this is a different kind of input than you've seen. We're going to enter a score and we're going to enter a second score and a third score. They're all going to be integers because most of the time your scores on a test are like 95, 97, 84, they're whole numbers. I'm going to enter these, but look, there's nothing in between these. All right. So what this program's going to do, and this is something that you all can use in the future, is every time it reads a white space, it's going to take, I'm going to put in 3 numbers with a space in between it. It's going to read in up to a white space and store it in score 1. Then it's going to read the next integer in up to the next white space and put score number 2. Then it's going to read again and enter score number 3. The program then will take those 3 scores, add them together, then divide by 3.0. The reason 3.0, we're scoring this in a double. Remember, double and floats are with decimals. So we're adding up the 3 scores that the user enters. We're dividing by 3.0 and assigning that value to average, which is a double. Then the program, just to reiterate things, is going to see out your average is average and del. Then this is where we get into the part where it's going to use an if statement. If the average of the three scores that you just entered is greater than high score, which is 95, the program is going to see out, congratulations, that's a high score. If it's not, suppose we enter 80, 80, 80, the average is definitely not going to be higher than 95, the program will do nothing. All right, let's go ahead and run this. Enter three scores. So I'm going to score a 97 on my first test, a 94 on my second test. I'm hitting enter instead of space. Either way, it reads up to a white space. All right, 97, 94, 96. All right, then I'm going to hit enter. The program takes those three integers in. It divides by 3.0. It then assigns the value to, actually I forget, to average, and then compares it to 95. 95.7 is higher than 95, so it says congratulations, that's a high score. So in this one, the average was greater than the high score, so the program initiated this line right afterwards. Let's do this again real quick. All right, this person didn't do as well on the test. 79. This time I'm going to put in a space. They made an 89. And then they got a 97 on the next test. I hit enter. This time, I want you to notice, I hit spaces instead of enter when I enter, but each time it reads up to a white space, inputs the data. I hit enter, and your average is 88. So nothing happened after that because if average is greater than high score, congratulations. All right, so this line just never happened. Type that in, play with it a little bit. Type in a few numbers. Right, there's an error that happens a lot that people forget about. All right, this program demonstrates how a misplaced semicolon prematurely terminates an if statement. All right, this one's straight out of the book, like 4.3, I believe. So I've made two integers, and I went ahead and assigned, I've declared the variable, and I've assigned it values of x, a value of 0, and y, a value of 10. All right. And then I just output that x is and y is. So it's just going to tell us x equals 0 and y equals 10. Now, if x is greater than 10, semicolon. This is a big mistake. It's one you're going to make, and it just happens to everybody. Some of these mistakes, it's actually a good thing that it happens. All right? The semicolon shouldn't be here. The semicolon means that if x, it does the comparison, then nothing. All right. This statement here will happen every time. It's always executed, no matter if x is greater than 0 or if x isn't greater than 0. It's always executed because you shouldn't have this semicolon here. So I'm going to run this. X is greater than y. You can see right there, x is 0, y is 10, x is greater than. So your program did make a decision, but it made the wrong decision because you had the semicolon right here. We get rid of that. All right, now run the program. X is 0, y is 10. This is false. X is not greater than y. So the line right after it, immediately after it, never happens. Proper, the way to write an if statement is if, no punctuation after this, then make it do whatever you want it to do. So far, all we've used is see outs. If this happens, see this out. But there's a lot more we can do with if statements beyond that. All right. Quickly, I'm going to run through the next one. I like to keep these videos under 20 minutes. So quickly, I'm going to run through the last one. So far, all the comparison we've did has been between integers, which makes it easy. One of the no-nos, it's not a no-no, but it's really difficult to do, and I strongly advise stay away from it, is do not um, use the comparisons between floats or doubles. All right. Here I've got two variables, a equals 1.5. Okay, I've got another double, b equals 1.5. So right now, these two are totally equal. I've declared variables and I've assigned them both the exact same value. So if I put, are these two equal now? Yes, they are equal. All right. But what I'm going to do is to a, I'm going to add 0.0000000 all the way up to 1. All right. I'm just adding a slight amount. All right. So we know now, because I've added something to A, we know that it's going to be greater than B. But I'm going to go ahead and I'm going to go ahead and do the comparison, the if statement, if A equals B. If A equals B, which we know it doesn't because I've added a little bit to A, it's going to output this statement. See out, both A and B are the same. All right. Now this is our first else, right? If this happens, see this out, all right? Else, if this is false, else means that this was false, output this, all right? I'm going to output this. This says right here, both A and B are the same. We know that A and B are not the same because we added a little bit to it. That's the problem with using floats or doubles for a comparison. Here we compared the two. Obviously, they're not the same, but this is such a small amount, all right? They think they're not the same. Run that again real quick. They think the program thinks they're the same. All right, key takeaways out of this: do not use floats or doubles for comparison. And this is our first introduction to else, which we'll talk more about in class or in these videos. Again, the if else, if this condition is true, do this. Else, if this condition is false, do this. All right, finished under 19 minutes. Great. Y'all have a good day.